Have you ever stopped to think about the force that keeps your feet firmly on the ground? It's gravity. This invisible tether connects you to the very center of our planet. It's always there, working silently and tirelessly in the background of our lives. We feel it every time we jump, only to be pulled back down. We see its effects when an apple falls from a tree, a story that famously inspired Isaac Newton. Gravity is the architect of our solar system, holding planets in their graceful orbits around the sun. It is the grand sculptor of galaxies, pulling together vast clouds of gas and dust to form stars and worlds. Without it, our universe would be a featureless, chaotic soup of particles, with no structure and no us. But what if I told you that this fundamental force, this constant companion in our cosmic journey, holds a deep and perplexing secret? What if the gravity we experience here, in our familiar world, is just a fraction of its true strength? Imagine that most of gravity's power isn't even in our universe. It might be leaking away, escaping into places we cannot see or touch. The mystery begins with a simple observation. Gravity is surprisingly weak. Think about it for a moment. You can overcome the gravitational pull of the entire Earth with a simple fridge magnet. This incredible difference in strength separates gravity from the other fundamental forces of nature, like electromagnetism. Why should this be? Why is the force that commands galaxies and black holes so feeble on a small scale? This question, known as the hierarchy problem, is one of the biggest puzzles in modern physics, and it points to a fascinating possibility. This possibility is that gravity isn't truly weak at all. Instead, the force we feel might just be a faint echo of its real power. Perhaps gravity operates in more dimensions than the three of space and one of time that we are familiar with. To understand gravity's strangeness, let's picture the forces of nature as a cosmic symphony. Each force plays its part, creating the harmonious reality we observe. The strong nuclear force is like the booming percussion section, holding the nucleus of every atom together with immense power. It acts only over the tiniest of distances, confined within the atom itself. Then there is the electromagnetic force, which is like the sweeping string and brass sections. It governs everything from the light we see to the electricity that powers our homes. However, there is one glaring omission in this beautiful symphony. Gravity doesn't quite fit in. It's like a lone, mysterious instrument playing a tune that doesn't fully align with the rest of the orchestra. Imagine you are a tightrope walker, living your entire life on a thin rope. To you, reality is essentially one-dimensional. You can only move forwards or backwards. Your whole world is a line. But from our perspective on the ground, we can see that your rope exists within a three-dimensional space. We can see the tiny ant walking around the circumference of the rope, exploring a second dimension you might not even be aware of. This is the core idea behind extra dimensions. They could be all around us, but simply too small for us to perceive. This changes everything. It means the absence of evidence is not evidence of absence. What if one force and one force alone was special? What if gravity, unlike everything else, was small enough to feel the effects of these tiny hidden dimensions? Our entire three-dimensional universe could be a giant brain floating within a higher dimensional space known as the bulk. We are trapped on this brain. We are living on the surface of a slice of reality. But gravity is different. The graviton is represented by a closed loop of string. It has no loose ends, so it's not tied to our brain. It can leak off our brain and journey into the bulk. This explains the hierarchy problem. Gravity isn't weak. We only feel the small part that stays on our brain. Most of its influence is diluted across all the extra dimensions. Our universe gets only the faint whispers of gravity's true power. The idea that we live on a brain completely changed the conversation about extra dimensions. It was a revolution in thinking, opening up startling new possibilities about the nature of reality. How do you test a theory as strange as leaky gravity? Scientists must be clever. They have to look for the subtle side effects these hidden dimensions might have on our world. This is the work being done at the Large Hadron Collider at CERN, on the border between France and Switzerland. The LHC is the most powerful particle accelerator ever built, designed to smash protons together at colossal energies. In these violent collisions, matter is annihilated, and its energy is converted into a shower of new particles. It is here that physicists hope to find evidence of new dimensions, looking for missing energy that could have leaked away. In 2015, science opened up a completely new window onto the universe, with the first direct detection of gravitational waves. This new field offers another potential way to test for extra dimensions. Let's imagine for a moment that the scientists are successful. Imagine they find definitive proof that gravity does in fact leak into extra dimensions. The first and most immediate implication is that our universe has a slow, persistent leak. Every time two objects interact gravitationally, a tiny, almost imperceptible fraction of that gravitational energy could be bleeding away. It would be seeping out of our 3 dimensions and into the vast, unseen bulk beyond. Over the immense timescales of the cosmos, even a tiny leak can have dramatic consequences. The gravitational bonds that hold large structures together would gradually weaken over trillions of years. Perhaps the most dramatic consequences would be felt by black holes. They would act as gateways, funneling energy out of our universe and into the wider multiverse, connecting our brain to the bulk in the most extreme way imaginable. Our journey has taken us from the familiar pull of Earth's gravity to the mind-bending frontiers of theoretical physics, where hidden dimensions and parallel universes might be real. And so, we are left on the shore of a cosmic ocean, with the waves of mystery lapping at our feet. Do extra dimensions exist? Is gravity the key that connects us to a wider reality? This is why science matters. It is not just about finding answers, it is about the journey of discovery itself. The adventure is far from over. The greatest mysteries remain unsolved, inviting you and all of us to keep looking up and to never, ever stop wondering about the true nature of our magnificent universe.